Yeah, good evening kids. So continuation of the electrochemistry class. So today we'll just move ahead. So last class we have defined your Daniell cell, galvanic cell. So I hope you know the difference between electrochemical cell and electrolytic cell. So we are now into the first part of this electrochemistry where we defined the reduction potential and we did some simple case of galvanic cell, that is your Daniell cell. Now there we define the term EMF of this cell. So EMF of this cell is defined by E of standard reduction potential of cathode minus standard reduction potential of anode. Cathode always reduction will take place, anode always oxidation will take place. Now as per IUPAC convention, when we tell reduction potential or electrode potential is taken as reduction potential, and then I told you if there is standard conditions. What are standard conditions? Concentration 1 molarity, pressure is 1 bar and temperature 298 Kelvin. You will see a top 0 there, E0 on the top superscript. So that means standard condition. Now once I know the reduction potential, I can find the EMF of the cell. But the point is, how do you find reduction potential? To find reduction potential, again and again, I think I have told you this so many times, wherever term potential comes, you have to have a reference point which we can take it 0. Even we took it in the last physics class also, last year also. Wherever you see a potential, you need to have a reference point. So to measure the reduction potential of any electrode, you cannot have a half cell and then measure the potential. You can have a full cell and then you can only measure EMF of this cell. So what is done? A reference potential half cell is taken. That reference half cell, which is used to measure the reduction potential, is known as standard hydrogen electrode. It is short form is SHE. So standard hydrogen electrode is used to measure the reduction potential of any other half cell now. So it is used in combination with another half cell whose electrode potential you want to measure, and they are completed as one cell, and then we measure it, and since this is taken as 0, other half cell electrode potential can be found. So first of all, what is SHE? If you see, it is a half cell is assigned 0 potential at all temperature, and it is used to measure standard reduction potential of other half cells. So as a matter of convention, it is assigned 0 potential. Now what it consists of is, if you see this diagram, it consists of a platinum electrode. Because it is inert, it does not participate in the reaction, it will provide its surface for the reaction to take place. So we will use this, and it is dipped in any acidic solution which can provide here H plus ions like hydrogen chloride gas or something. So this, like, see, suppose in the case of Daniell cell, if you remember, we have electrode itself of Zn. Here electrode, you cannot have electrode of hydrogen, so electrode is taken as this thing, and for hydrogen gas is pumped into it. So that hydrogen gas is pumped into it. So either the reaction will go as H plus electron will give you hydrogen gas. Here if you see reduction taking place, or hydrogen gas gets broken down into H plus ion where oxidation will take place. So this is your one half cell. Please remember, this is your one half cell. So basically it contains of platinum electrode which is dipped in an acidic solution, and pure hydrogen gas is bubbled through it. Now the conditions are taken as standard conditions. The standard condition I told you, 1 molar concentration, pressure 1 bar, and temperature is 298 Kelvin. Now this is one half. So if you remember that one half of the cell, and as again matter of convention, it is always taken as anode or left hand side. Whichever cell you want to measure the electrode potential is taken as cathode. Suppose I want to measure for copper, so that will be taken as cathode. So just this becomes the anode half cell, and then the other thing becomes the cathode, and then again, like whatever we did in the last class, the case of your Daniell cell, reaction takes place. So suppose in the case of this thing, now you will have, it is how the representation of this is hydrogen, SHE is always on the left hand side. So the representation, now this is new thing, last class. In the representation of the cell, if electrode is different, so the electrode will come first. So this denotes electrode, because there we did not have to worry because it was always your Zn only. So here you have to write this electrode comes first. Now this hydrogen gas Now goes here H2G 1 bar condition. This is again aqueous condition. Normally standard conditions are always taken. This denotes, this denotes salt bridge, very good. And this is Cu2 plus aqueous 1 molar goes to Cu. So this is always taken as cathode. Now this EMF is measured. This EMF is measured using voltmeter. So this EMF comes out to be 0.34. At standard condition is 0.34. Now what is EMF? This is measured. This you can only measure. So this is measured using experiment. So this 0.34 is equal to ER0 minus EL left. EL left is hydrogen. This by convention we are taking it as 0. So as a matter of convention we are taking this thing as 0. Here this thing we will be taking it as 0. So that means this will come out ER0 is equal to 0.3 volt. So standard reduction potential of Cu is 0.34 volt. Similarly, if you want to measure for zinc, instead of copper electrode, that right hand side cell we converted into Zn electrode and Zn solution, Zn-SO4, it comes out to minus 0.76 volt. So SRP of this will be minus 0.76 volt. Now this has a great significance in chemistry. What positive means, what negative means, if it is greater what to do, if it is lesser what is the meaning of that. So that I will explain in the next video. What is the meaning of this plus, this is coming out plus, this is coming out negative, what is the meaning. In the meanwhile you have a table given in your NCERT. There are plenty of values. Normally they will give in the question, you don't have to worry, but it is my sincere request you remember these values. These values you have to remember. The standard reduction point of fluorine 2.87, the maximum. Ag 0.80, copper is 0.34, hydrogen is 0, F is minus 0.44, Zn minus 0.76, and then you have the negative least value is lithium minus 3.05. These values remember, it will really help in solving the questions in case any kind of, because most of the questions will be based on this reduction potential only. So what is the meaning of this, I'll explain in the next video. In the meanwhile, just note down these values and remember these values. Just read that NCERT or even my notes also you can read for this sheet. In the next video we will just explain what is the meaning of this. Thank you.